Hello and welcome to Sales Projects. Today we're going to test different methods of post-processing to get the best optical clarity from SLA printed microlenses.
In the kitchen, you scrub the toilets.
I'm filming this intro, like the last one, after the fact, and I just wanted to give a quick synopsis so we can get right into making it. What I'm doing today is I'm testing using different materials to post-process these lenses after they're being finished and before they go into curing. The first one is we're going to be using a wash, the second one we're going to be using isopropyl alcohol, and the third one is we're going to be using gloss. Now it's going to be with or without wash, with or without isopropyl, and then both of those are going to have a with or without gloss. So that's why there's a total of 4 and 1. The one is a test one where it's literally just water and curing. Those are going to be the two constants. They all will get dipped in water and they will all be cured for the same amount of time, which is 60 minutes with no heat. So let's get to making the lenses. So these two lenses are lenses that I need to give to my teacher for a testing sample, and I cured them for about 60 minutes at a high temperature, and as you can see, sort of, they are I'll take some photos of them. They are still optically clear, so that means I can cure it for about 60 minutes, and thankfully the curing time will not affect the transparency of the stuff. So we're all good, which means we're going to continue with the other lens tests where we're just going to do the isopropyl and the other stuff. So right now we are doing the isopropyl and the wash. So the only problem that we have is that the ones on the wash need to stay on the bed, and then the ones that are going only the isopropyl will actually have to, well, just be removed so that I can have them separately. So I just need to pop them off before I show the rest of them. We were able to print 4 of the things at once. And also, this is using a new tank of resin, so this should be perfect, which, I mean, even just seeing the first one that printed, these look amazing. So, let's do this, not to ruin it. Now we're just gonna take them, pop them off. But I'm gonna leave the back 2 on there. Wow! Came off nicely. Put that, I guess, there for now. My advisor actually suggested that I do it this way. Just use like a sort of a sharp razor-ish. And now, I don't mess around. Now, again, the reason why I'm making these is so that I don't have to, it's so that my advisor, who has a light testing rig, can actually go and test the focal point on these things, which is pretty cool. He's gonna take a laser, have it like point into the center of the lenses, and since, well, you only need one to test it, what do you call it? Have it go right through that lens. Okay, so we have that. And once it goes through that, he can actually see like, where it focuses. And we can see then, after that, how accurate it is to our simulations in Code 5, which is an optical software that we're using. I'm focusing more on the fabrication with SLA. My friend Kevin, who's my partner on this project, is working on the simulation stuff. I mean, I will have to do some amount of the simulation stuff, but he's focusing the majority of it on there. So, I'm just gonna pour a little bit in there. Now, one thing that I realized when I was doing an earlier print was that if I use adaptive layers, the change in the layers will actually result in a frosted look. So this is pointed at the finest with a constant layer height. So this is 0.025 millimeters. So let's just take it and dump it in here. Now, when I did the other one, it came out perfect. Oh, wait a sec, wait. Yeah, all right, so now we're just gonna wait for this to dry without touching the lenses. Come on, it's a little bit slippery. So that one is isopropyl 1, this is isopropyl 2. So the reason why I'm printing this version instead of the 8 one also is because the border on the sides will allow him to affix it into the testing jig itself, or rig, sorry. A jig is what you use for woodworking. Well, at least I'm in a safe environment. So, that is both significantly dipped. It is very interesting to see that they didn't immediately fog up like last time. So, in the meantime, while we're waiting for that to dry, I'm going to quickly to do that stuff. I'm going to dispose of this safely, and I'm going to wait for that stuff to dry. Now, once the isopropyl is dry, and that is dry, we're going to have them both go in the water, because the water needs to remove the cancerous materials, and then we're going to cure them, because that should help it work. Actually, before we cure them, we're going to add the gloss. So, I don't have special UV curing resin, but I have this Rust-Oleum clear lacquer, and it should be usable for this type of stuff. I guess it'll just be a good test because this was free and technically didn't cost me money. So I can add that in my report saying it didn't cost me any money, which technically none of this is costing me money, but that's sort of like saying you got a free car from your parents so it didn't cost you any money. It technically did, in some way. So I guess I'm going to explain sort of why I'm doing this while it's doing its thing. The reason why I'm sort of getting around to this stuff is because I want to test the best post-curing methods or post-processing methods to get the best optical quality lenses. And the only problem with that is SLA, at least the materials that you use with SLA fabrication, can be a bit iffy just based on the post-curing processes. Because with 2PP or 2-photon polymerization, it's a bit more repeatable and accurate just because of how high-tech the machines are and the, well, post-processing methods are. This is sort of, you wing it, you hopefully get it right. For example, some people are saying sand the lenses once you're done. That'll remove that little bump and ridges of the layer lines and make it more flat. The only problem is though, yeah, you really can't sand a 1mm lens and maintain the full profile of it. And the other thing is, we're going for accuracy. So if I sand the profile, it could greatly change where the focal point is, or honestly, I could even mess it up so badly that it doesn't have a focal point. So that's sort of why I don't want to mess around with that. Now, I have heard things about using a vacuum chamber and some other stuff to get it done, but I plan to do that in maybe even next week's video, just to see, but it's really cool. We do thankfully have this thing, which is a vacuum chamber. I will have to learn how to use it to be safe, but as of now, yeah, I'm not gonna mess around. Oh, it is a vacuum chamber. Good. So, but apparently there's other ways, like you have it submerged in water while it cures. It's gonna be really interesting to see. And one thing that I do have to say I'm very thankful about is the fact that throughout all of this stuff, the video that I posted last Sunday became the second result on all of Google for if you look up SLA printing microlenses. So I'm really thankful for that, and it got me, yeah, it was really nice to show that off. So, yeah, we have about 4 minutes left on the wash, and let's see if these little guys are dry yet. Definitely slippery still. They're a little bit dry. Thing is, they're not fully dry yet, but they are getting pretty darn dry. And so one cool thing is that, well, at least what I did, which I don't know if it's noticeable in the slightest, but in SolidWorks, which I'll pull up a photo of what I did here, I put an actual like square cutout on the back so that when I'm in Preform, the software, which I'll also show here, I'm actually able to position the supports behind it. So that means I can increase the amount of supports on the back of it, which again, I set it to manual focus so it won't zoom in on anything else. I'll show a photo of it. I'm able to place things around the lenses. Wow, that is really clear. It's like looking through a pane of glass. Wow. But getting back to what I was saying, that allows me to place it on there. Now, thankfully, this process should be repeatable when I do the 8x8 array. I thought it would be called a matrix, not an array, because an array is a single dimension array is, no. An array is a single dimension, a matrix is 2 dimensions, so, I don't know. But, with this, I should be able to replicate it with the 8x8 matrix and put a thing around it so that I could put support all around the edges. Because the support doesn't matter. We can clip off the support, we can sand the border, but we can't mess around with the back of the lenses. So if, let's say, a support ended up right on the back of that lens, it would ruin it. So what do? You put it around it. You could even put it in between it, but that's sort of getting a little bit too crazy. So yeah, but I'm genuinely surprised how well this stuff came out. Wow. I honestly have no clue why no one has done this before. Now, I would like to restate, I specifically mean microlenses, not bulk optics or large scale lenses, microlenses. The resin that Clear V4 has a index of refraction of 1.52, which I know in the grand scale things it acts very different, but the fact that it has a sort of closer index of refraction compared to, like, I don't know, it being 0.8 or 1. I mean, 1.5 to 1.6 is not a huge amount different, but it should be able to show at least some amount of, yes, this lens does work and the focal point will be sort of close to where you want it to be. Well, again, we're gonna figure that out later. But I just feel like it's just absolutely awesome, and you can actually mathematically and scientifically tell that these things are gonna work. So it still boggles my mind that nobody is doing this stuff anywhere. I mean, I looked on YouTube, I even looked up IEEE research papers, and I'm getting nothing. So if you see this video when you're looking up how I did this in I don't know how many years, just credit me if this ends up actually doing anything. So, all right, you got 25 seconds left. All right, so while we're waiting for that stuff to drip off, I'm gonna put the ones that have the isopropyl on them through the water, just so I don't mix them up with the ones that have gone through the wash, because ideally, I can't tell the difference because they're both optically clear, but we'll see. So, as per usual, we just take them and we dip them in the water. A little bit of a swirl, and we look to see if it ruins it. I don't see anything. Granted, there's a lot of particulates in the water, which no clue why that is. So I'm just gonna take a paper towel and hopefully skim whatever oils and stuff is at the top. It's like hydro dipping, but worse. Almost made it. What's that one? Oh yeah, that's that. Alright, and now this one. So there's going to be 2 constants to each of these things. To all the post-processing. Water and the curing time. See, the test that we ran on the other stuff showed that a curing time of 60 minutes makes it strong and does not affect its optical clarity. And the water is necessary just to remove all the exceptionally cancerous chemicals, which is the reason why I'm wearing gloves. And apparently it didn't drip all the way. Okay. Alright, okay. Maybe you don't know how to drip into the thing. So now let's just take this. Looking at it, they look the same. If this ends up being where all of them don't make a difference, I would genuinely be surprised. Now technically there's one combination that I haven't tried yet, which is isopropyl with the TPM. But this is sort of a trial, because if TPM ruins it, then isopropyl is probably going to ruin it too. Wow. It's amazing how easy they come off with a sharpened spatula instead of the super flat ones. say that, and now it doesn't want to come off. Ah, damn. Well, okay. So, there's like a 60 to 7% chance that when it popped off, due to the geometry of it, it didn't get messed up. I'm hoping that it didn't. Thankfully, it doesn't matter, because we're going to designate this one as the one that gets covered in gloss anyway. Now, how we're going to do that is we're going to be smart, and we're just going to... There you go. So if I'm watching this video back trying to tell what it is, the one with the flat edge is the one that I clipped, and dropped. This couldn't be perfect, could it? Nope. So now just take them and get all that cancer off. Oh, wow, that was quick. Okay. So it's definitely frosted. It definitely frosted. I just can't tell. So it's definitely frosted, but it's still... I'd have to say it went from having a 80% opacity to like a 60 to 70%. Like, you could see the layer lines and you could see that there's something there, but it's not super discernible. Like you might scratch your eyes to make sure that it's just not your eyes first before you look through something like this. And here we go. All right. And yeah, they're both frosted, and you could sort of see. I can't tell if it's layer lines or just particulates. Wow, but you could definitely tell the difference. How do I do this smartly? Which hand would I want to? Okay. So before I do any curing, I'm going to take a photo of how different just the bases look on the two. I mean, you can 100% tell that there is a definite difference. We're going to put this in the garbage. Okay. So now I have two options. I can let them dry, or I just get them ready. So, see, this is why I made the clipped edge. Actually, well, first I need to clean the build plate off. This is why I love doing scientific stuff. As long as it's somewhat of a process, it's scientific. And by the way, while I'm waiting for the stuff to print and cure, I'm currently watching 2.5 Men, so my grandfather would be proud. You're gonna take the cracked isopropyl and one of the two, no, the cracked TPM and one of the just isopropyls, and now we're gonna spray some gloss on them. Oh, you know, do we want to do that after we cure? We'll do it after they cure, because I guess it'll be more of an ending process for that. So, we're going to take them and throw them in there. We're going to put them on the same area. Or, we're going to put one across from the other. Technically, they're still a little bit wet, but that did make a huge difference for the other stuff. And one thing I also will note, there is a surprising lack of extra, extra resin on the prints, which you might say, well, duh, it's because you removed it, which, yes, I know that makes sense, but it's just interesting to see. Now that it's all done, we're just gonna wait for them to cure. We're gonna spray 2 of them with gloss, and then we're gonna see under the microscope which one is better. And then after, probably in the next video, I'm gonna say which ones that using an optical test actually ended up, well, being better. All right, so we have 2 lenses One, of course, through the TPM, the other one with the isopropyl. And we're now just gonna spray it with the clear lacquer. So, you gotta do a nice even coat. So I think I'm gonna just spray it like that. So, hopefully it doesn't push it over. All right, so that's one. And now, two. So while this dries, it's interesting to see that the one that went through the wash, or the TPM, actually looks clear again. And the reason for that is the same reason why, well, the original prints that I had done failed. What happens is, when you have the resin on the, well, print itself, the extra stuff that comes right after you make it, it fills in the microscopic ridges, or the layer lines, that are caused by, well, additive manufacturing like this, where it's one layer over the other. So in between that layer, right here, is that resin. And so when you remove that resin, you see the layer lines, where it's fused together. Now, of course, when you sand it, you remove those layer lines. But with this stuff, once you remove it using either the isopropyl or the TPM, you see them. So when you do it and you use gloss, that gloss, since it's clear, will fill in those gaps and should work enough to make it so it's back to being more transparent. Of course, well, that's just me saying that, because we don't know yet. But in previous tests where I just sort of said, is this even worth trying, on, well, other prints that I've done, not specifically lenses, it's actually worked, which is pretty cool. And it will be interesting to see, once I leave these out in the sun for a good bit, if they do end up curing differently. I mean, I have certain prints and certain lenses that I left out that have become a tinge yellow. And it would be interesting to see, when I create the aspheric lenses, if that affects the chromic aberration that comes from it. So, yeah, we're just gonna wait for this to dry. Which should be, dry and recoat times, 20 minutes. 20 minutes, okay, so dries to touch in 20 minutes, to handle in half an hour. So that means all I need to do is wait about half an hour, and I should be able to take the microscope and start looking at these. That's just so cool, the fact that it fills in those gaps. So, what ideally can happen is, once we get to use a scanning electron microscope, we'll be able to see how bad the surfaces compare. And we should be able to see the actual layer lines, which will be really cool. I'll be able to take a 3D printed version, like a FDM printed, and a SLA printed profile of it, and put them together and see if they're about the same, which would be pretty cool. So, let's wait for it to dry, and yeah, let's get to the microscope. Okay. So I have finally finished post-processing all of the lens. Now, I'm not gonna tell you which method was used for each of these lenses. We're just gonna see how they look. Now, I do have it written down somewhere, and you can smell which one is which, but we're gonna see now on the microscope how good they actually look. So, starting off, we have lens number 1. This is not gonna be very fun to focus it. And thankfully, this time I'm actually using a, well, there you go. Would you look at that? Wow. Now I will say that one of these lenses, I don't remember which, I did touch by accident. But that looks pretty darn good. Let's take a quick photo. All right, so we have that lens. As you can see, it's pretty clear, no frosting, and it looks pretty darn good. I mean, of course, it does have some surface imperfections because I touched it, but not massive ones. So that's number 1. Number 2. Wow. Wow, it looks even better. Wow, that's almost no surface imperfection. That looked like it's just stuff from the back of it, which is crazy. That looks really darn good. I mean, that is focused. That's how good it is. I mean, trying to focus any more is just, I mean, like, look at that. There's almost no surface imperfection. That's almost perfect. So, wow, that's amazing. Oh wait, I gotta take a photo of it. I am doing the science part of this. All right, good. And also, the best part is the stuff is cured, so I can touch it with my hands. That's why I don't have gloves on. So now we go to this one, which... which is the lens? Huh. Oh, okay, so it would be the top thing right there. That's the edge. Okay, okay. Wow, look at how perfect that one is. So you can't really see it, but it's that center to top one-ish. It's like the one that's a little bit above the top. See, like, here's my finger. It's, it's really big. So, it's, yeah, it's the biggest bulb out of that, but that also just looks absolutely perfect. So now let's go to the next one. Yeah, and I did just take a photo of it. Wow. Yeah, definitely, I have definitely upped the quality. I mean, look at that. That's also absolutely, positively perfect. And there's almost no surface imperfections at all. Wow. That is absolutely amazing. If I hadn't written these down, I would have probably lost which one is which. All right, and now we go with this one. Which I could, as you can see, it's a bit frosted and the surface is a bit ruined. Wow, so this is the only one that just looked like garbage. And now, I am going to bring up two extra ones. These are just ones from previous tests that I originally was going to give to my teacher, but I ended up not being able to give it to him. So we have this one. Whoa, that's a strong smell. And these, I've been very safe not to touch the lenses themselves. So let's just focus in on there. Wow, would you look at that? They look almost perfect. I mean, look at that. You get that perfect round curvature. Granted, the side profile, not so much. But the actual curves of it are amazing. Let's take some photos. It's almost like I'm doing a science project. Oh wait, I am. Wow, look at that. That is absolutely amazing. I mean, it's like, oh, this is crazy. All right, and wow, those blow the other ones out of the park. I mean, you get a near perfect circle on those. I mean, perfect. Let's see, anything happens if I change the focus? Besides doing that. No, look at that. That is absolutely flawless. Now, I want to see what happens when I get a side profile of it. Oh my God, look at that. It's like you're looking through the, what do you call it? Looking through like, I don't know, barbershop window. Come on, give me that nice old side profile. Look at that. They're so clear you can't even tell, except for the fact that the side profile, well, at least the side of the thing didn't print so straight because this was the thin model. This is the V1 actual versus the V1 thin. The actual comes from, these are the actual dimensions that we'll be using. It's not just some sort of randomized test. Wow. Look at that. Oh wait, what was that? I wonder if I could lower the LED brightness and get something better. No? Okay, we'll just stick with this. But look at that. So, we have all of these done. Now, you can pause the video here if you really want to figure out which is which, but what I can tell you is that I'm pretty sure I mixed them up. Oh wait, no, I didn't mix them up because I did keep them in the right ones. So, let's just zoom out a little bit. Okay. Wow, that was awesome. And my phone did screen record. Let's go. Okay. So, to start off, the first one was just the isopropyl alcohol. So this was cured using, or the process was printing, dipped in isopropyl alcohol, and then the isopropyl alcohol was removed by some water, and then from there, it was put straight in the curing chamber. And this one was pretty darn good. Then, the next one, oddly enough, is the TPM wash with gloss on it, that spray gloss that I used. And it came out really, really well too. Then the next one we have was the no extra methods part. It was just water, it was just printed, then water, and that was it. Granted, I did let it drip for a bit longer, but that's just because, well, yeah. I messed up a little bit with how I wrote it down, but I was able to sniff it and figure out what it was. This is isopropyl with gloss. So it's clear plus the super clear. So that's why this, arguably, just looking through it, is like looking straight through a window. And then we get to last but not least, which is just the wash. And as I predicted, it's not as egregious, but as you can see from the photos, it definitely still has that frosted look. It would be interesting to see if this still is somewhat optically viable, but overall, it was not great. So now the fun part is I have to transport this home on a very bumpy road. And then one of these was, what do you call it? With the gloss, the other one wasn't. But one thing that is interesting, that is a side note, is that with the orientation that I used, that was suggested by someone in the comments, so thank you very much for that. The fact that I put them in a triangle formation, or the fact that I had it angled with one of the corners down and one of the corners up, so that the stuff would drip off a lot nicer instead of just having it be on the bottom where it would pool up, ended up actually creating a really, really nice edge. It's perfectly straight. So whoever suggested that, I'm gonna have to look up in the comments. Thank you very much for suggesting that, because that has made this a huge difference. So thank you very much. And now we're going to go finally use the green screen in the video, and we're gonna tally up the results. Since I don't really have a way to transport it home because I brought my bike here, I decided to use drink tokens, which are just extra ones that I had left over. I engraved them myself on the laser engraver, but regardless. So the ones with the clear ones mean that they have gloss on them, unless there's extra ones. But regardless, the ones with the clear ones have the gloss on them. The blue ones indicate that they used isopropyl, and the orange ones indicate that they used the wash. So, for example, this one, blue, this one was created just using isopropyl. This one, blue and clear, which means this one used isopropyl and the wash. That one is just the wash. That one is isopropyl and water, gloss and wash, sorry. This one, as you can see, has nothing on there. And that one was just the, what do you call it? Just water, it was nothing. Then you have these two, which these were sort of just, I don't know, fun to have. So, yeah, and you can even see from here, I mean, the differences in clarity. I mean, that's the isopropyl one. The one with the gloss and wash came out amazingly. The one with just the wash came out the worst. And then the one with the gloss and the, come on, focus. Focus. Okay, so the one with the gloss and the, what do you call it? The gloss and the isopropyl actually ended up coming out the best, possibly. And then we got the two extra 8x8s. So, yeah. There you go. Now it's focused. But yeah, honestly, they came out really, all of them came out really well, and you could tell in the video. So, let's go do that stuff. So before we get into which one is the best, I just want to say that I brought it home in a Tupperware. I literally just super glued it to the bottom and I got it to work. So what we can see is that the top three were wash with gloss, isopropyl with gloss, and then nothing. Just water and just curing, which I find very interesting, but also sort of, I guess, what we planned. We thought, or at least I thought, that removing the substance from the lens, by removing the extra resin from the lens, using solvents, will result in the layer lines being visible. The problem with that, of course, is that, well, it's going to remove the optical clarity of it and create, well, a frosted look, which was seen in the wash and the non-gloss, just using isopropyl versions, which is a little bit interesting to see. Also, the fact that the isopropyl did not remove as much as the TPM or the wash, despite the fact that it's a lot older, or the wash is a lot older than the isopropyl, but I don't know. So I just find it really interesting. What else the good thing is though, since all these printed, we will be able to use them for the for the light testing, which I will probably just film a little bit of that just so I can show you guys, but that's gonna be done Monday, Wednesday, I don't know. It'll happen after this video, so it'll probably be in the third one. So yeah, I mean, it was very successful. We got them all home. They all look amazing, and you can see even from the videos that they look really good. So as we can see, that our hypothesis was confirmed, which is going to be awesome when I'm writing my report for this week, and that it is actually possible to get a super optically clear lens without sneezing. Because the first time I dropped them, the second time I sneezed and dropped them, but the third time I held in the sneeze and I didn't drop it. I only messed up the other ones when I sneezed once, but they were the non-important ones, so who cares. But yeah, the next week what I'm going to try and do, as long as I can get that vacuum chamber working, is I'm going to test just totally different methods of curing and post-processing. I'm talking using vacuum chambers, letting it sit for a week, which I may or may not have already started, and a bunch of other stuff. So I'm really looking forward to this project, and the amount of data and just knowledge I'm getting from this is absolutely amazing. I mean, I came into this knowing about curing and SLA fabrication, all this stuff, but now I'm using it on a specific application, and it's absolutely just amazing. It's so cool to actually put my knowledge to work and then learn new things based off of that. I mean, I thought it was going to be more clear based on the fact that there were no layer lines, but, well, now after seeing it the first time, I know for a fact that it wouldn't. So there's a bug over there. So if you have any other tips or comments or ideas of how I should cure these lenses so I can document them to get the best optical clarity, put it in the comments below so I can, well, test it out, and hopefully I'll be able to actually do it this week. And other than that, I'll see you next week, Sunday, 8 a.m., the usual time. Thank you so much for watching, and thank you so much for being with me on this part of the project.